Hello, hi everybody. Welcome to week 5. Today we will talk about the networking. This reference you can use it as your personal reference. Content. At first I will talk about the networking revision. This is the basic thing of the this unit. We will learn about OSI, MAC, DNS, hub, switch, and router. We also learn about the net, common protocol, tools, how to sniff a hub or switch, man in the middle attack, DNS or host. So this thing we will learn today. Okay, what is OSI model? OSI model stands for Open System Interconnect, which is inside the model there are 7 layers which allow any computer to talk to any other computer through a network or the internet. It uses standards and protocol to wrap data in packets as they head into the internet wire and to unwrap them as they come out. It's not all every layer will be used. For example, the router will use layer 1 until 3. Most the internet service don't use layer 5. The exception are web conferencing and internet TV. The digital telephone system skip many of the higher levels. The OSI was retrofitted to existing practice and technologies. So this is the picture of 7 layers of OSI. So we start with the higher is application, presentation, session, transport, network, data link, and physical layer. The physical layer will be used, the more to below it will use to transmit, and then more to the higher it used to receive. The first layer is we call as a application layer, which is a interface with actual program being run by the user. After that is the presentation layer. It used to manage port allocation, encryption, and variation in application layer syntax. After that is the session layer. It used to manage process-to-process communication, window file sharing, and synchronizing data streams. After that is a transport layer. It's responsible to different type of error correction and end-to-end communication. Below that is network layer. It routes packets from one IP address to another. Seems like a routers. Below that is a data link layer. It the purpose of this layer is to do the arrangement of bit being transmitted. It composes the media access control layer and the logical link layer. This is an example for the hub, bridge, and switches. The last one, the most below is a physical layer. It's like a wire, radio, electric signal, NIC, COX, twisted pair cable, or internet. It's about the physical things. Various protocol or technology will handle the mapping from layer to layer. MAC to IP, ARP. Public IP to IP routing protocol. Public IP to private IP, we call it a NAT. IP to domain name, we call it a DNS. There is no layer responsible for authentication. Layer 6 is responsible for encryption, but layer 6 is often not implemented because encryption is just a option. It really depends on the engineer how to do is it they want to put the encryption or not. Okay, MAC is stand for Media Access Control. In practice, each NIC, which is a network card, have their own MAC address, which is in the form 48 hexadecimal number burned into each NIC. The ARP protocols manage the matching of MAC address into IP address. ARP allows IP address to be mapped to MAC addresses. So you can consider each device. For example, our handphone also have their own MAC address. I mean, like every client, every server, every device have their own MAC address, which is MAC address is content of the location of the ID of the network card. DNS. DNS stands for Domain Name System. It's basically is a system of name server distributed around the internet which translate URL domain names into IP address. And all system which is susceptible to attack. So this is the example of the attacks. Hub and switches. Link, transport, and network layer device which interconnect other device and computer using network cables and wireless transmitters. This device has multiple NIC. Hub ensures all packets received to all connected devices. Switch. A switch ensures all packets received to device in their corresponding destination as defined by MAC address. Switches use ARP to link the MAC address of their interface with IP addresses. Many switches, when overloaded, revert to hub-like behavior. So this is an example of the switch. The link. Bridge. Bridge acts like a switch that can link to subnet or link to part of a network which use different and incompatible physical layers or cable. Bridge can break security by linking trusted lines to the internet. A router can pass packets to a particular interface by checking the destination IP address and by using a routing algorithm to calculate the most successful path through a network of router. NAT. Okay, what is NAT? NAT stands for Network Address Translation. It's a type of router which can open an IP packet and readdress it. Originally developed to allow many hosts to share a common IP address. Incoming traffic is allocated to different internal IP depending on the port used for each incoming packet. It is also often used as a poor-man proxy server because of the ability of NAT to hide the internal details of a private network. It is often the principal features of firewall. Microsoft ICS is a common implementation of NAT. So this is a common protocol that we learn. First is IP. IP stands for Internet Protocol, which is its address data container used to carry TCP and UDP packets through a network or internet. ICMP. It stands for Internet Control Message Protocol. It used by OS to exchange error messages and by network tools such as ping and traceroute. It doesn't use ports. Another common protocol that we learn in this slide is a TCP. It stands for Transmission Control Protocol. Basically, it's a reliable but asynchronous data container carried by the IP protocol. It creates connection over which packets can be exchanged reliably and the correct sequence. Sometimes it refers to as TCP/IP. Used by many internet services such as FTP, HTTP, Telnet, POP, as defined by their respective path. It uses a three-way handshake, SYN, 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 to establish a connection which cannot be spoofed. What is a split handshake? Basically, it's a combined aspect of the normal three-way handshake with the simultaneous open handshake. Essentially, a client sends a SYN packet to a server, intending to complete a normal three-way handshake. UDP. UDP basically stands for User Datagram Protocol, an reliable but fast data container carried by IP protocol. Packets are sent without prior connection but may be lost or arrive out of a sequence. It is used for multimedia streaming, telephony, and DNS query. It uses ports to define the services. Source IP is easily spoofed because the source address is never checked. Ports. This is the well-known ports. Start from 0 until 1023. Service like Internet using 23, FTP 20 and 21, DNS using port of 53, HTTP using port of 80, HTTPS using port of 443, mail using 110.25, and SSL using port number of 22. For registered port, 1024 until 49155 is registered by company for proprietary purpose. So this is for registered ports. Dynamic port, which is a private port, it starts from 49152 until 95535. Is allocated by runtime by processor. Its particular ports are known for exploit that use them. Port number are not bound to particular service. Any port can be used basically. A web server can operate in port 2 and telnet can operate on port 1080. IP address. Some IP address ranges are reserved for particular types. For example, private blocks IP address used behind the proxy server. Default gateway 000. It represents all possible IP address. This one for loopback address 127.0.0.1. Usually, if you want to develop like a dummy website, so we will use, of course, we will use with, the local host first before we upload to the real server. And then, if you want to put the dummy website in the our local host, we can use 127.0.0.1. It's a refer to the local host. D class multicast address, so this is the address, the range. E class reserved address, this is the range. So this is the range for the broadcast address. Network tools. So this is the tools for network. It's a network diagnostic utility to testing connection. For example, you want to test the connection. Is it our PC have is it our PC, for example, you want to say, is it our PC have a connection between the google.com? So if that the question, we can just straight away open the CMD and then put the ping and the ping the google.com. Type in the CMD ping google.com. If the google.com replies, so that's mean your PC have connection to the google.com. So that's mean it also gives another meaning, your PC have internet connection. It's send, and basically this thing is send ICP packet to IP address and wait for ICP packet and reports to time delay in millisecond. If domain name is used, ping will initiate and use the result of a DNS query. Ping may be blocked at firewall to prevent network reconnaissance. Traceroute. For Windows, we use Traceroute. It's a tool for tracking the path taken by IP packet. Send a sequence of UDP or TCP packets. It collects the result ICMP temp exit packets. It displays the source IP address and host name of the ICMP packet in sequence to show the path taken by the original packets. Another network tool we will use, so this thing is a basic tool. We use IP config for Windows and ifconfig, or Windows Unify Winnie PCFG. So Windows Unify usually we don't use lah, because these are the all-timers things. So of course for we use in Linux and Windows IP config. Linux we use ifconfig. This command we can use in the CMD. I mean the CMD is the black one. It used to display or configure the local network interface. It also display the current client IP address. For example, if you want to check our IP address on our PC, in our PC we can use ipconfig. It also can be used to initiate a DHCP request and refresh the DNS caches. Netstart. Netstart is a command, CMD command that we can use to display all current network connection including TCP and UDP and other protocol. It also indicates the presence of Trojan and spyware. Packet sniffing. What is packet sniffing? Basically, it's like an activity that we use to record IP packets on the network. It's originally designed to help the solve problem in networks. Many internet-based services expect to receive username and password in plain text. Computer users get lazy and use the same username and password. So this is the popular packet sniffing in the market, such as we can Snort, Wireshark, which is both come in Windows and Linux version. For lab session, I already teach you how to use the Wireshark. So Wireshark is an example of the software that we can use to record the IP packets. So this tool, Wireshark, that we learned in the lab before, is a text and GUI version for available for Windows and Linux. It lists packet contents on the screen and logs them to a file analysis later. It summarizes types of packet intercepted. Snort is another software that is a text-based IDS with packet sniffing and logging abilities. It separates packets into IP address and port number. It's easy to search packet using grep. Okay, what is man-in-the-middle attack? Basically, it's an attack where the attacker secretly relays and possibly alters the communication between two parties who believe that they are directly communicating with each other. All layers of the SI are susceptible to attacks. Application layer, such as virus, worm, Trojan. Session layer, null attack for Windows PC. Presentation layers, DNS, DOS, DNS cache poisoning. Network layers, ARP cache poisoning, ARP spoofing. And the last one, physical data link layer, sniffing and playback. This and others will have and will be attacked. So this is the blue screen. Okay, common attack. So common attack, this is the example of the common attack, like a sniffing a NIC and hub. Sniffing means capturing the IP packets and display and analysis them. So this we learned before. We can use to sniff by using the Wireshark. Common sniffing program include the Snort and internal Wireshark. Local analysis is set as Prometheus mode. Sniffing program record packets presented to NIC, including all packets passing through the hub. Switches are also susceptible to ARP cache poisoning and MAC flooding. Switches act like hubs when overloaded. Ping of death. Basically, is another common attack that sending on oversized ping packet will cripple the network stack of all Windows 95 computers. It's sending many ping that cause a DOS. So basically, the objective of the ping that is to denial the services of the server. For example, you have your own server. I want to attack your server and make sure your server cannot operate. How to make sure your server can operate? I will send the many pings. We call it a ping of that to your server, and then your server cannot operate. So that's mean your friend or your customer cannot access your server after the attack of the ping of the that be sent by me. Another common attack is the ARP cache poisoning. Basically, it's a maintain a table of MAC address and their equivalent IP address. It sends out query who has IP 239.254.2.15. Replies are added to ARP table and come from any IP address to any time. Okay, how it works? Attack attach his PC to the network. It sniff to find target IP address. It sends a homemade ARP reply nominating his MAC address as corresponding to the requested IP address. ARP adds the attacker MAC address to the ARP table. In future traffic to the target goes to the attacker. Attacker reads packets, doctors them, and send them on the target who is none the user. Another attack component is a MAC flooding. Basically, in this attack, the switches use ARP to map MAC address to IP address. When boot up, switches operate in hub mode when they learn the MAC address attached to each port. Switches has limited memory and computing power. When overloaded, they revert to hub mode and broadcast all packets to all interfaces. Okay, how it works? Attacker attaches to his PC to the network. It sends out multiple invalid ARP responses. It switches overloads and revert to hub mode. Attackers collect all packets from the network. DOS. It stands for Denial of Service attack. Basically, it's like an attack, which is the aim or objective of the attack is to make sure the server, for example, you have a server, make sure your server cannot be accessed by another user. In nice word, you can say it's a cyber attack in which perpetrator seeks to make a machine network resource unavailable to its intended user by temporarily or indefinitely interrupting service of a host connected to the internet. Basically, it aims at server on the internet. The goal of deny service to legitimate customer or user. ICMP ping. Attack send a stream of ICMP echo request packet. The solution: we need to change IP address or block ICMP traffic at the ISP or router, or buy a router appliance that drop pings packet really fast. So this is another DOS technique. Scenes. Basically, it's a attacker send a stream of scene packet. Each scene packet consumes memory on the server while it sends the scene packet and waits the returning SCK packet. Attacker never sends the SCK packet. So how to solve this issue if we found this kind of the attack? Is we store scene packet info the memory, it return as scene cookie to the attacker machine. When the attacker machine return an SCK packet, the memory of the cache is allocated. Another solution is after receiving the attacker's SYN packet, the target returns a SYN packet containing the wrong info. The attacker should then resend a RST packet, after which connection from the client are now accepted. Okay, smooth packet application attack. An attack send a ping to the broadcast address of the victim networks. This send the ping to all IPs on the subnet. The original ping has a proof return IP address, which is the address of the intended victim. Each IP reached by the original ping replies to the victim. Okay, how to solve the issue? Just disable the filter broadcast address. Another DOS technique is a UDP flood. Basically, it's a flooding the UDP packet to the random ports of the victim as fast as possible. The target machine will respond to each packet and with a ICMP destination unreached packet. So, how to solve this attack? By turn off ICMP destination unreachable. Ping of that. This thing is also we can categorize as a DOS technique, as I mentioned before. It's like a big size of ping that we will send to the susceptible PC. It will cause a reboot and unstable machine. So how to solve this problem? We need to use a newer OS or product or patches the old one. Another DOS technique is a teardrop. Basically, it's a fragmented packet is sent to the attacker, but the part has been corrupted and cannot be put back together. Server consume resources requesting restarting. Many crash the server. The solution is we need to use newer OS or product or patch the old one. Next is LAN attack. Basically, it's amplification attack. A packet with spoof source IP address is sent to the victim. The return address is the same as the destination address, so the victim machine ties itself it knows by answering back it to itself. The solution of this attack is we need to update and patch our OS. Smarter switches and hub detect this and block it. Normal bandwidth sufficient to mount an attack. Almost all operation systems and routers are vulnerable. All servers are vulnerable because they have implemented the TCP protocol. The solution is to block the source IP, but no solution if mounted by a botnet. So this is the reference for this DOS attack. DDoS. DDoS basically is stand for distributed denial of services. Is a malicious attempt to disrupt normal traffic of a targeted server or network by overwhelming the target or its surrounding infrastructure with a flood of internet traffic. A DDoS involves simultaneous attack on a single site by zombie machine infected by bot. Each bot controlled by a bot header originally through IRC channel and now through HTTP. A bot header's botnet may range in size from a few hundred to million of infected PC. Each bot is actually a small server program which has installed itself and is capable of launching DOS attack, sending spam, infecting other machine or all of the above. It is also spread by the Trojans or by worms. How to stop DDoS? Basically, it targets children for a reason. Find out who are your enemy. Are you victim of extortion? Have you offended a script kiddie? Or is it any their political motive? There is another option. First one, we can get a new IP address. We can use a mitigation strategy such as red limiting and black holing. Another technique how to stop the DDoS is DDoS mitigation. Use cloud service to observe or filter your traffic. Very cost effective. Scale up during the attack only pay on the bandwidth unit. DDoS attack also use botnets. So get rid of botnets. So this is the example of the new attacks and defense. The case study. You also can help to elevate the problem for others by sanitizing your PC. The sanitizing is like clean up your PC. You can use a package sniffer or Netstar to monitor your outgoing traffic. Get firewall which block out outgoing traffic. Get AV which is filter website, downloads and email such as Avast. You can read security updates and patch your software, which is mean update your software. Turn your PC or router off when you're not using it. Block all ports you don't use. Use a non-admin account. This is the defense strategy. I will talk to your ISP in terms of filtering, red limiting, or port knocking. Test your own vulnerabilities. Diversify hardware. Make sure you use the cost benefit always. Some services do need to be protected. Some services should not be on the internet. How to use port knocking. All ports are closed. Daemon monitor port traffic statefully. Remote user send packet to a particular sequence of port. Daemon recognize the knock. Open a port for the user IP. User connects. Okay, IPv6. Basically, IPv6 is the most recent version of the IP. The communication protocol that provide an identification allocation system for computer or networks and route traffic across the internet. Basically, it's a new protocol new codes and new bugs. Even though actually it's not really new, but it's considered latest. Botnet tunnels over IPv6 are anonymity. Most IDS not capable to monitoring IPv6 traffic. IP over DNS. DNS system can be misused many ways, using the text field to store content, tunneling through DNS to bypass a firewall. The IPv6 address includes your MAC address. It reduces the need of for IRP tables. It reduces the need of NAT, but it breaks anonymity. Anyone with your IP address know your MAC address. How about MAC address are not fixed? Anyone can install a tool which changes their MAC address. It's great for bypassing MAC address filtering, sharing internet connection, and man-in-the-middle attacks. Android phones and tablets change MAC on reboot. There was kernel code identified that will randomize a MAC address. Apple since changed MAC address before they do Wi-Fi association. So this is the case study for DDoS. This case study is happened in 2014. Okay, I think that's all for this slide. So at the end of the slide, I will give the tutorial like an open question in the canvas. I hope you can participate since recently I just got the email from the management which is student need to participate in the canvas as replacement as the active student participation in class. So right now we know there is no physical class, so we just have a visual class, which is means like a online recorded video only. So this is very important for the university to measure the student participation. So that's why I have an idea. I just every week I will upload the new question, which is I think is related to the test. So I hope all of you can answer the question. So this is the question. Which of the following malware can be used to facilitate key login activities? The first one, COS30015, CORDRED, Trojan Window, and Stanix. So please answer by giving the comment in the canvas. Okay, so that's all for today. I hope you can enjoy this lecture and don't forget to submit your lab in the next week. So you have a problem, just uh, do a message in Microsoft Team or email me. So I hope I can help you through this kind of the communication. So that's all for today. Okay, thank you.